Welcome to This Explainer. Today we're diving into something really fascinating, a totally culturally accepted evening habit that is, quite frankly, silently hijacking our neurobiology. Yep, we're talking about the traditional nightcap. In our modern American lives, where digital overload, chronic stress, and attention fragmentation are literally everywhere, optimizing our micro-mental health and our sleep has absolutely never been more critical. And yet, millions of us are unknowingly sabotaging our cognitive performance, healthy aging, and longevity with just a single evening drink. So what we're going to do is decode this massive interconnected biological journey. We'll look at exactly what happens when alcohol meets sleep, going right from the microscopic level of your brain receptors all the way to systemic whole-body recovery. Let's get into it. So does alcohol actually help you sleep? Well, it's a question rooted in this massive biological paradox. If you've ever had a drink before bed, you know it might make you pass out faster. It definitely acts as a sedative. But here's the thing. Passing out is not the same thing as sleeping. While that drink acts as a rapid trapdoor into unconsciousness, it is fundamentally destroying the architecture of your restorative sleep. That sedation you're feeling, it's actually a neurochemical illusion. It sets off this devastating chain reaction across your entire brain and body, which severely impacts your deep work capabilities and your emotional resilience the very next day. Okay, let's dive into this masterclass syllabus. We're going to cover 1. The sleep aid paradox. 2. Neurochemistry and brain receptors. 3. Altering sleep architecture. 4. Circadian rhythm disruption. 5. Autonomic strain and recovery. And finally, 6. Optimizing sleep hygiene. Starting off with Section 1, the sleep aid paradox. In a society obsessed with productivity and health optimization, so many of us are just looking for a quick fix, right? We want to easily transition from the high stimulation of our modern work environments straight into that deep rest required for lifelong vitality. But this quick fix is inherently flawed. Get this, a staggering 20% of American adults actually rely on alcohol as a self-administered somnogent, basically a sleep aid to help them fall asleep. That is literally 1/5 of the adult population relying on a central nervous system depressant just to shut down for the night. And the societal and economic burden of alcohol-related sleep disorders, it's estimated to exceed $18 billion annually. We're basically trying to cure our modern sleep deprivation with a substance that practically guarantees poor sleep quality. Moving right along to Section 2, neurochemistry and brain receptors. Now, to really understand this paradox, we have to look at the brain's highly delicate chemical networks the exact moment that first sip is metabolized. Your capacity for deep, focused work relies on a very, very delicate balance of neurotransmitters. So think of your brain as having a chemical brake pedal and a gas pedal. GABA is the brake. It's your primary inhibitory neurotransmitter that calms down neural activity. Glutamate, on the other hand, is the gas, the excitatory neurotransmitter that keeps your brain alert and active. Well, alcohol acts like a massive foot slamming on the brake. It artificially spikes GABA, enhancing its calming, sedative effects. And simultaneously, it actually blocks the glutamate gas pedal. This dual action completely depresses your central nervous system, which is exactly why you feel so drowsy. But, your brain is incredibly adaptive, and it recognizes this artificial suppression as a massive threat to its homeostasis. Now, what's really interesting about this slide is how alcohol artificially manipulates your body's natural sleep drive, which is known as Process S. Throughout the day, as your cells use up energy, this metabolic byproduct called adenosine builds up in your brain, specifically in the basal forebrain. This extracellular adenosine is exactly what creates sleep pressure. Well, alcohol actually accelerates this whole process by blocking an enzyme that normally clears adenosine away. So your brain gets completely flooded with a false, rapid signal telling it that you are completely exhausted. But here is the catastrophic catch. As the alcohol is metabolized and leaves your system right in the middle of the night, the brain undergoes this violent rebound. Remember how alcohol suppressed the glutamate gas pedal? Well, your brain naturally created more receptors just to compensate for that. So when the alcohol wears off, glutamate activity surges by over 200%. That is a massive state of hyperexcitation. It causes something called excitotoxicity, where your neurons are firing so incredibly fast they can actually damage themselves. This neurochemical whiplash is the exact reason why you wake up at 3 a.m. with your heart racing, your mind spinning, and you are totally unable to get back to sleep. That brings us to Section 3, altering sleep architecture. Moving from the microscopic neurochemistry of receptors, let's zoom out a bit and look at macroscopic brainwaves. How do these chemical shifts actually destroy the normal phases of your sleep? Well, sleep is a highly structured, dynamic process. Normally, you cycle gracefully between deep, slow-wave sleep, which restores the body, and REM sleep, which restores the mind and consolidates memories. But alcohol violently distorts this architecture. In the first half of the night, while alcohol is still in your blood, you get thrown rapidly into heavy, slow-wave sleep. But in the second half of the night, as that massive glutamate rebound we just talked about hits, your sleep becomes incredibly fragmented. Crucially, REM sleep is severely delayed and suppressed. The result? Your brain is completely starved of the cognitive restoration required for learning, emotional regulation, and deep work the next day. This is a truly vital point when we're talking about brain health and aging. Clinical polysomnography data actually shows us that even though you might be unconscious, the sleep is microstructurally abnormal. See, normal restorative sleep relies heavily on sleep spindles, these precise electrical rhythms in the brain. Alcohol completely suppresses these vital spindles, replacing them with abnormal, slow delta oscillations. So you aren't actually resting. You're essentially in a state of chemically induced anesthesia. Your brain isn't cleaning out metabolic waste or consolidating memories like it's supposed to. Let's head into Section 4, circadian rhythm disruption. So the crucial point is, expanding beyond just sleep stages to our body's master clock, alcohol directly attacks your ability to produce melatonin, the key hormone that regulates your sleep-wake cycle. Research shows that just a moderate dose of alcohol before bed inhibits a specific enzyme required for melatonin synthesis, which actually reduces your production by nearly 20%. And because melatonin is also a super potent antioxidant that protects our cells from aging and oxidative stress, suppressing it doesn't just ruin your sleep for one night, it actively accelerates cellular aging over the long term. And this circadian disruption triggers a total cascade of physical chaos. First, alcohol completely dysregulates your brain's thermoregulatory set point. As it metabolizes, it causes nocturnal hyperthermia, those really uncomfortable night sweats. It also acts as a diuretic, which fragments your sleep even more with frequent bathroom trips. On top of all that, it deeply relaxes the muscles in your head and neck. This upper airway relaxation dramatically increases snoring and your risk of sleep apnea, leading to intermittent hypoxia. That means your brain is literally starved of oxygen, which causes systemic inflammation and explains that pounding headache the next morning. Section 5, autonomic strain and recovery. Now we transition over into systemic physiology. How does all of this impact your body's ability to actually handle stress? Well, alcohol forces the cardiovascular system to work in absolute overdrive during the exact hours it should be experiencing its deepest rest. To measure this, we look at heart rate variability, or HRV. This is a crucial metric for longevity and physical resilience. It essentially measures the balance between your parasympathetic system, that's your rest and digest mode, and your sympathetic system, the fight or flight mode. A high HRV means your body is recovered, it's adaptable, but metabolizing ethanol completely suppresses your parasympathetic nervous system. And this brilliantly illustrates what's happening under the hood. Analyzing millions of data points from WHO wearables shows that even a single drink locks the body into a sympathetic fight or flight stress state. On average, HRV drops by 7 milliseconds, and resting heart rate spikes by 3 beats per minute. Realistically, this translates to an average 8% drop in your next-day physiological recovery. So instead of healing cells and reducing inflammation while you sleep, your heart and liver are up working overtime to process a toxin. And honestly, the damage isn't just confined to the next morning. It is a massive shock to the system. Wearable data and clinical studies reveal something pretty wild. It can actually take up to 4 or 5 days for a person's heart rate variability to fully rebound back to its baseline after just a single night of drinking. That is nearly an entire week of compromised physical resilience, lower cognitive endurance, and biological strain, all from just a few hours of evening relaxation. Moving to our final part, Section 6. Optimizing your sleep hygiene. Let's move to and see how this builds into something actionable. Having explored the root causes and systems biology of this issue, how do we actually take control of our longevity, our daily energy, and our brain health given this data? How do we build a practical framework for mitigating this autonomic strain? Well, the absolute golden rule of biological optimization here is timing. Step 1. Implement a strict 3 to 4 hour cutoff rule. If you are going to drink, finish your last 1 hour before bed so your body can fully metabolize the ethanol before your head hits the pillow. Step 2, hydrate aggressively to give your liver a hand. And step 3, moderation is completely non-negotiable. Exceeding 1 drink for women or 2 for men exponentially multiplies those sleep-destroying rebound effects we were just talking about. Furthermore, you can actively biohack and rebalance your hijacked neurotransmitter systems through targeted nutrition and intuitive behaviors. To rebuild your suppressed GABA, try incorporating magnesium-rich foods like spinach and almonds. To calm down that surging excitotoxic glutamate rebound, rely on heavy hydration and brain-protecting omega-3 fatty acids like you'd find in salmon. To naturally restore the dopamine that alcohol artificially spiked, lean heavily on high-protein breakfasts and rigorous exercise. And finally, to reset your master biological clock and restore serotonin and melatonin, make sure you're viewing bright, natural sunlight within the very first hour of waking up. When we view health through this interconnected systems biology lens, it all comes together. Micro-mental health affects sleep, sleep affects deep work, and deep work absolutely affects our lifelong aging process. Every single system influences every other system. The science is incredibly clear here, guys. Alcohol is not a sleep aid. It is literally a sleep architect's worst nightmare. So, as you aim to optimize your cognitive performance, your emotional resilience, and your overall quality of life, you really have to ask yourself, are those few hours of artificial evening relaxation truly worth nearly an entire week of systemic biological stress?